Graham's law of diffusion states that at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Mathematically, this definition can be used to derive a formula for Graham's law of diffusion. Mathematically, we say rate varies inversely as square root of density. From there, we can come over here to say R by removing the mathematical variation sign. Remove this and replace with equals to K. Then we have R. Then we have R equals to K over root of D. If we cross multiply, we are going to have R root of D equals to K. That is, we can now say R1 root of D1 equals to R2 root of D2, where our R1 is equals to rate of diffusion of gas 1. R2 is equals to rate of diffusion of gas 2, whereas D1 is given to be density. Let's say D1, D2, they are densities of gas 1 and gas 2. Having known that, from here we can proceed to have the general formula. How do we have that? We can say from here we can call this equation 1. Come over here, we call it equation 2, and then this one we call it equation 3. We can say multiply equation 3 by 1 over R2 root of D1. From there we can now have R1 root D1 multiplied by 1 over R2 root D1 to equals to R2 root D2 multiplied by 1 over R2 root D1. Okay, having known that, we can divide root D1 by root V1, then we divide R2 by R2 here. Therefore, we write down the leftover. You have R1 over R2 to be equals to square root of D2 over root D1, which is the same thing as, or you write it as R1 over R2 to be equals to square root of root D2 over D1. This is the general formula. This is the general formula. Of Graham's law. Of diffusion. Of course, this general formula is what all students is expected to know. Now, but from here, we can derive some other formula which can be used in dealing with different calculations given to students in examination, such as in WAEC, NECO, and in JAMB.